Okay, let's dive into one of the most mind-bending topics out there right now. Generative AI. I mean, how on earth can a piece of software, a machine, just dream up an image? Not just any image, but one that's totally original and looks as real as a photo you take with your camera. It's wild, right? You know how it works, right? It all starts with just a few words. You type in a sentence, a simple prompt, and boom, out pops a stunning, photorealistic image made from absolutely nothing. You've seen the kind of stuff models like Google's Imagen can do. They literally turn words into entire worlds. But here's the kicker. It's not magic. Not at all. It's math. So that's the big question we're tackling today. How in the world does a computer learn the essence of what an image even is? I mean, how does it get so good at it that it can just create a totally new picture, something that has never, ever existed before? All right, so here's the secret. It all comes down to a special mathematical formula. You can almost think of it as the code of reality for pictures. If an AI can crack this code, it can figure out what makes any image look, natural or real.
So this formula, it actually has a name. It's called P of X or P of X. That's just the fancy term for the probability density function for images. But what does it do? Well, it's pretty simple actually. It's like a judge. It takes any image you throw at it, any random jumble of pixels, and it gives it a score. If the score is high, that means the image looks natural, like something you'd actually see in real life. But if the score is super low, it's basically just random, meaningless static.
And I want to be super clear here. This isn't some obscure niche idea. This function, P of X, is, well, as Professor Michael Allard says, it's the absolute center of everything we do in machine learning and image processing. The takeaway is this: if you can master P of X, you can basically do anything you want with images. It's that important. Okay, this might sound a little abstract, so let's try a cool way to visualize it. I want you to imagine a gigantic cube, but this isn't a normal 3D cube. It's a 400-dimensional one. Wild, I know, but stick with me. This cube represents every single possible 20 by 20 pixel image patch that could ever exist. Now, let's take billions and billions of little patches from real photos, trees, faces, cars, and just throw them into this cube. What do you think would happen? You'd find that almost the entire cube is totally empty. It's like a vast desert of just nonsense images, random static. All the real, natural image patches, they would all clump together in one tiny, super structured little area, like delicate threads or filaments. That's the space where our magic formula, P of X, has a really high value. So, okay, everyone knew this P of X formula was the key. But for decades, the million-dollar question was, what is the formula? And the first approach was, and you might find this kind of funny, to basically just guess. Yeah, seriously, scientists tried to sit down and define what makes an image good and then write a math rule for it. And what was their best guess? Well, the most popular idea for a long time was that good images are smooth, where pixels are usually pretty similar to the pixels right next to them. So they cooked up a formula where the smoother an image was, the higher its score would be. Makes some sense, right? Well, there was one big problem. When you actually tried to use that formula to generate new images, all you got were these blurry, super simplified blobs. It turns out reality is just a whole lot more complicated and detailed than just being smooth. So clearly the whole guessing game was a total dead end. It just wasn't working. And that's when a completely revolutionary new idea hit the scene. The thinking went, instead of trying to guess the secret formula, what if we could get an AI to learn it? Learn it all on its own just by looking at tons of data. What if it could learn the formula from chaos itself? Okay, and this brings us right to the modern breakthrough. It all starts with something called the forward process. And here's what that means. You start with a perfect, crystal clear image. Then you deliberately start to destroy it. You add just a tiny bit of random noise. Then you do it again and again, step by step adding more and more noise. You keep going until the original image is completely gone, and all you're left with is a screen full of pure random static. Now this might seem weird, but here's the crucial part. We now have a perfectly predictable step-by-step recipe for turning any real image into noise. And that simple idea leads directly to the core of the whole diffusion breakthrough. Because if we have a perfect recipe for turning an image into noise, well, could an AI learn to do the exact opposite? Could it learn to reverse that process? Could it actually learn to create a masterpiece, starting from nothing but that pure static? And this, right here, is where the magic happens.
The AI starts with nothing but a screen full of random noise. Its only job, its entire purpose, is to look at that noisy mess and just try to predict what a tiny little bit of that noise is, and then subtract it. That's it. And then it does it again, and again, and again, over and over. With every single step, it's like it's peeling back a layer of chaos. And slowly, but surely, a real structure starts to emerge from the static. After hundreds of these tiny steps, it does the final cleanup, and there it is. A brand new, crystal clear, high-quality image. And here's the genius part. By learning how to perfectly reverse that destruction process, the AI has, without us ever telling it the formula, implicitly learned the secret code of reality, P of X.
So you might be wondering, why did this specific method, diffusion, just completely take over the world of AI? Well, there are a few huge reasons. For one, it's built on really solid, provable math. It's not just a bunch of trial and error like some of the older methods. Second, the results are just ridiculously good. We're talking state-of-the-art, best we've ever seen performance. On top of that, it's super flexible and can be used for all sorts of different things. And, maybe best of all, the core concept, just adding and then removing noise, is actually pretty simple and elegant at its heart. And I'm not exaggerating when I say the impact of this was absolutely explosive. We're not just talking about a small improvement in making pictures. This breakthrough kicked off a whole new era of research and development across pretty much all of artificial intelligence. Just to give you a sense of how fast things moved, check this out. In the very first year of this research, maybe 50 papers were published on diffusion models. A year after that, 300. And by the third year, the number just completely skyrocketed. It felt like the entire field was in a dead sprint to explore this new frontier. Let me just put one single number on it for you. More than 1,000 research papers were published on this topic in just a 2 to 3 year window. That kind of exponential growth, it's almost unheard of in science. It just goes to show you how unbelievably powerful and promising everyone realized this technology was.
But I want to leave you with one final, kind of wild thought. Professor Elad makes a pretty bold prediction. He says that in just a couple of years from now, this entire field we've just talked about will probably be obsolete. It'll be replaced by something even better, even more advanced, and totally different. And it's an amazing reminder that we are absolutely not at the end of this story. We are right at the very, very beginning of watching machines truly learn how to create.